This video is to address task number 6 in week number 5. In task number 6, it asks us to use our three-dimensional kit to graph the planes x minus y equals 0 and y minus z equals 0. My three-dimensional kit is GeoGebra. Then we are to use a three-dimensional kit to graph the line A if it exists, defined by the intersection of the two given planes, and then describe line A including all of its intercepts if it exists, and if it does not exist, explain why. The first thing that I wanted to start off by showing is that the plane x minus y equals 0 is shown in blue on my graph here. And then the plane y minus z equals 0 is shown in pink. These two planes are clearly intersecting, so line A does exist. I kind of had a feeling that that would occur. What I did is I started the same as I did in task number 5. I isolated my plane equations to have y by itself, and I was able to see that y equaled x, and then that was the first plane. And then the second plane was y equals z. What I noticed then is that we can apply the transitive property. So if we know that y equals x and we know y equals z, they're both equal to the same value of y, so we can actually conclude that x is going to equal z via the transitive property. So with that being said, if they're all equal to each other, they're all going to have an intersecting point at 0, 0, 0. That is also true of their intercepts. All of them are intercepting at the point 0, 0, 0, where my cursor is right now as we see this spin. I really liked this problem. I thought it was really cool. It resembled, in my interpretation of it, it resembled the three-dimensional version of the two-dimensional y equals x. And in the line y equals x, we know that in two-dimensional space, y equals x is just a line, a diagonal line that slices through quadrants 3 and 1. And so I thought that it was interesting because two quadrants were basically untouched in that line. And in here, we are seeing that with the planes being intersecting, there are going to also be two octants that are untouched as well. So we're basically looking for the octants where no blue or pink plane is going through them. And what I found was that down here, the plane, or the octant that included, let's see, the y-axis is the red one, x-axis. So this one is the octant that is going to be the positive, negative, negative octant. There is no plane intersection in there of either plane. And then the other plane that, or the other octant rather, that is not being used is over on this side. And this is going to be the, let's see, this one is going to be the negative, positive, positive. Negative, positive, positive octant, and that is because we are negative in the x, we are positive in the y, and if we were to move above sea level, we would be also positive in the y as well. So that one does not contain anything. So I thought that was an interesting trait that you know, all of them are shared with between the two-dimensional space and the three-dimensional space. But again, the conclusion of this task is that line A does exist, and again, line A is formed if we look at all their intercepts. Because of that transitive property, they will have the same intercept, and all of the intercepts will be at 0. So that is really what is interesting about this line.